Good morning, ladies and gentlemen. Today we're going to be learning about the area of a triangle. What I'd like you to do is look at the square and ask yourself how many square units make up its area. As you can see, if you know about the area of a square, you can do 4 units times 4 units. Oops. 4 units times 4 units equals 16. We get that because the length is 4 units and the width is 4 units. You can also get it by actually counting up the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we know then that the area equals 16, and we would say square units. All right, now look at the triangle. How many square units make up its area? We're going to move the grid over. Well, you could do the same thing, which is counting them up. 1, 2, 3, 4, 5, 6. If I move this one over here, that's 7, and then 8. Because this and this make a whole, and this would make a whole. 2 halves make a whole. So the question I have is, they both have 4 units on one side and 4 units on the other, but different areas. Why do you think the areas are different? Go ahead and pause the video and talk about it with your class and see why it is that they are different. Okay. You and your classmates probably discussed that, obviously, the square has 16 complete units, where the triangle has only half that amount. And even though the base of the triangle is 4 and its height is 4, if we were to do that, it would be length times width equals area, and we would get 16. Wait a minute, that doesn't match the same as we got before, which was 8. So there's a question mark here because these do not equal one another. Let's see why it is that they're different. Knowing that both of these shapes have the same height or length and width or base, yet have different areas, match the formulas below with its corresponding shape. So what I'd like you to do is to pause the video for a moment and go ahead and try to match up the formulas with the shape that it corresponds to. All right, let's see how you did. So here, I'm going to start off with the one that I'm most familiar with. It's similar to the process of elimination. You're going to go through those items that you know that you're more familiar with. So for example, I know that I can eliminate area length times width from the triangle side. I know it's going to go with the square. And notice that underneath it is its formula. Area equals L times W. And make sure that you know this symbol, this X, means multiplication. It does not mean a variable in this situation. So let's see. I noticed too that this says area equals base times height. Well, I knew from the previous slide that if we were just to do base times height for the triangle, we would get the same answer as the square. So I have a feeling that this is also for the square, which lets me know that regardless if we said base times height or if we said length times width, they mean the same thing. Which leads me to this belief that base times height divided by 2 would be for the triangle, and that's the same thing as saying half. I'm going to check my work to make sure that that truly makes sense. For example, the last example we had, they had 16 units in it for the square. So if we were just do base times height, 4 times 4, it would be 16. And we know that a half of 16 is 8. Now, if we wanted to substitute those values, we would say area equals 1/2 of 4 times 4. 4 times 4 is 16 because we always do the parentheses first. And we'll see that 1/2 of 16 is 8 square units. And by the way, square units is a lot to write out. Sometimes I do units squared. Sometimes you can just do square units. It's however you feel comfortable. Now let's check our work over here for the square. Sure enough, the length and the width happen to be the same. For squares, they always will be. So area equals 4 times 4. Area equals 16 square units. Look at the figure below. Which equation best represents how to find the area of this figure and why? Go ahead and take a moment and vote on your own, please. Okay, let's see what it is that you chose. And I want to encourage you too to hear what other people chose as well. So if you'd like to, I would encourage you to pause the video and see if everybody around you has the same answer. And remember, what's the worst case scenario? Somebody has a different answer. Somebody's going to be wrong. So be it. That's life. Go ahead and pause the video. All right, let's see. This one for me was a bit more difficult because you'll notice that I like it when they're nice and even, like when it happens to look like this. But that's not the case. This one's a little bit more difficult, but that's okay because I can still find the base and the height. So let's see. The base is 1, 2, 3, 4, and the height is 1, 2, 3, 4. So area would equal 4 times 4, which is 16. Well, let's count up and check our answer. 1, 2, 3, 4. I think if we put that together, that would probably make 5. These two would make 6, 7, and 8. Wait a minute, it's 8. It's not 16. So A is not the best representation. So for B and for C, we have to determine which one is better. Well, I know that base times height is the same thing as saying length times width. So I'm going to move over here to C and see if that works better. So area equals, what's the base? The base is 4 times the height, 4. And we're going to divide that by 2. Let's see. 4 times 4 is 16. And divide that by 2. And sure enough, we get 8. That makes more sense. So I think C is the best answer. And just to let you have another trick, make sure that you go through the questions. What's the height of this figure? What's the base? And then using those two values and the formula you chose, determine the triangle's area. Remember that it's a step-by-step process. Find the height, find the base, and then jump into the actual formula or equation to solve for it. Don't feel like you have to take it all on at once. And by the way, when in doubt, draw it out. It's okay to draw a picture. All right, so my question is, why does the formula for a triangle work for the first picture and for this one? Use the pictures below for extra help if you'd like. Go ahead and pause the video and take a moment to discuss that. Okay. Well, one thing that really helps me is that I try to remind myself that if I have a triangle and if I were to build the square around it, I would see that that triangle is exactly half of that square. For example, when I put these two together, that makes one full triangle. If I took them apart again, look, it creates another full square. Same with this over here. It cuts it evenly, right in half. If we were to rotate this, you'll see it's been cut right in half. That's where that formula comes from. When we multiply the base and the height by 1/2, it's because half of a square is a triangle. Or you could say if you take a square and you divide it into half, I have to connect the diagonals, divide it into half, take a square, divide it by 2. Sure enough, you're going to get a triangle. You'll get 2 triangles. Remember, the biggest clue I want to remind you to do when you're taking a test or whenever you're doubting yourself, remind yourself that you have a lot of knowledge and that whenever you're worried about, wait, I don't know if it's the right formula, try it out. Try the different values and see if they work. What's the worst thing? They don't work. At least you know then, and that you can then revise your work. I hope this has been helpful, and feel free to come back and watch this anytime you need a little extra help. Thanks.